We are in Precalculus, lesson 3-11. Today is January 9th, 1/9. Let's put it on our papers, 1/9. You have your name on your papers. Let's begin. Word problems, example 1. Anyone want to read?
Teams A, B, and C are playing a game of string. Each team has attached a rope to a metal ring and is trying to pull the ring into their own area. Team A pulls with force vector A equals 6I plus OJ. OJ Simpson. Team B pulls with force vector B equals 4I minus 2J. Team C pulls with force vector C equals negative 3I minus 3J. Which team will win the game?
Yeah, that's a good question. So if you had to think of these terms, so if you did the absolute value of these terms, what is the length of these vectors, essentially, is what I'm asking. Which one of these is the longest? Let's just take a guess. Who do you think is going to win, A, B, or C? Which of these numbers looks like they'll come out to be bigger in terms of the lengths? These are hard to see because we're talking about the hypotenuse, not the two legs. I can't just do 4 plus 2 because that would be 6. Obviously, these all look like they would add up to 6, but which one of these is bigger? Who are we going to guess? Who are you putting your money on? Which team is stronger? Daisy, Rochelle, take a guess. A, B, or C?
When in doubt, always choose B.
Okay, Daisy says B.
I don't know, actually.
When in doubt, give up and choose and guess C.
No, it's
So
always
Rochelle's
B.
choosing C.
Oh no, I'm not choosing C.
Come on, take a guess. What are we
No,
getting? What are we doing?
I'll choose B.
B. Okay, you both are going with B.
Wait, B and A. Can we do that?
You can't choose 2. You get 2/3
What if
chance.
I
You get
secretly-
1/3 chance
what
of
if I
getting it correct.
secretly choose A?
No, you get to secretly choose the right answer, and that is going to be whatever answer you choose right now.
Yeah, Rochelle.
Okay, B. It's B.
All right, it's B. Everyone agrees it's B. Mr. Sindel knows the answer. I'm not going to say it. Which team will win the game? Okay, so what we're essentially doing was we're trying to see which of these magnitudes is the biggest. Do you remember the formula for magnitude? We've gone over it a few times. You have it in your notes yesterday if you need to look at it.
Yes.
All right, let's find the magnitude of each of these. Magnitude of vector A. That's going to be equal to, what's the formula? How do I do this?
I remember. Oh, square root of A squared plus B squared.
Yep, so square root of 6 squared plus 0 squared. 6 squared plus 0 squared. So 0 squared obviously is just 0. 6 squared is?
36.
Square root of 36 is?
6.
Oh, there it is. All right. And that makes sense, right? Because if you're just pulling in one direction, that's all you got. You got 6. All right, let's find the magnitude of the next one. Daisy, you want to do this one for us? All right, vector B. I'm finding the magnitude. Finding which one is biggest. What is the formula for finding the magnitude of B? Tell me what to write.
So it's square root of 4 squared plus negative 2. Or is it? Is it negative 2?
Plus negative 2.
Yeah, squared.
Perfect, okay. And what is 4 squared?
16.
16. What is negative 2 squared?
4.
Okay, and I know how to do 16 plus 4. Mr. Sindel has gone to, I don't know, first grade. When is that? Square root of 20. And I don't know if you have calculators for this. You might have to just figure out where square root of 20 is. Well, let's do this. So what is this? What is the square root of 25?
So it's gonna be in between. So it's gonna be like what, 4.5 probably.
Yeah, so we know that this guy is definitely smaller than 5, right? Because it's 25. It's smaller than 25, and we know that 25 is 5.
But it's greater than 4.
And we don't really care if it's greater than 4 because we know that 5 is definitely smaller than 6. Team A is winning over Team B so far. All right, let's do Team C. Vector C. I am finding your modulus, your absolute value, your distance. What am I doing here? Formula.
3 negative, square root of negative 3 squared plus negative 3 squared.
All right, 3 squared and 3 squared makes
16.
close.
18.
There it is, 18, because 9 and 9 make 18. And square root of 18 is definitely smaller than square root of 20, which happens to also be smaller than 5. So, which team won?
A.
Team A.
Boom.
with a smiley face. Yay. Good job, team A. And since that's our answer, always box your answers. Team A will win. Cool, cool. All right, we have some more questions about this problem. What is the magnitude of the team's combined force acting on the ring? All right, so I need to combine all of these teams together into one vector. And this is the cool part about vectors. And when you take physics, do we take physics? No? Okay, well, if you take physics in college, when you take physics in college or community college, wherever that is, vectors are really cool because when you break them down into their components, you can turn them into just one vector. You can take many of these other vectors, turn it into one vector just by adding all their components. Let's add all of the i's. Here we go. Add all the i's. 6 plus 4 minus 3 is?
-1.
Close. 6 plus 4 minus 3.
Oh, it's 7.
7, yep. So I get 7i. 7i. And Daisy, add all the j's, you get? Add the j's, you get 0 minus 2 minus 3, which is? Minus 2 minus 3. You got this, Daisy. I believe in you. 0, minus 2, minus 3. They all add up to?
I'm kind of just having a break.
Here, I'll help you out. 0, don't care about. -2 minus 3 plus the inverse. -2 and -3 combine to?
No, 5.
5 or?
-5.
-5. There it is. Okay. We're good. All right. -5. So I have minus 5j. Okay. That is the entire vector. Now that we have this combined vector, I need to find the magnitude of that combined vector. So it's the same thing that we did up here, finding the magnitude with this vector now. So find the magnitude of this guy. Magnitude of this guy is equal to, how do I do it?
It would be square root of 7 squared plus -5 squared.
-5 squared, there it is. And that's the same thing as 49 plus 25. 49 plus 25, 70. There it is, 74. 74 is not a prime number. You can divide by 2 and you get 30. What is it, 37? And then 37 is a prime number. So that doesn't reduce very nicely. There it is. That is the combined force on the ring, square root of 74. And if you want to approximate that, because it's asking you for a decimal, oh yeah, it said round to the nearest tenth. So let's treat that as a decimal. So square root of 74 is 8.6. That is approximately equal to 8.6, and I don't know what our units are. It'll have the units for you on the homework assignment. 8.6 is the answer you're looking for. That means you are going 8.6 units in Team A's direction. Somewhere in Team A. Not maybe exactly in Team A. In fact, we know what direction we'll find because we're going to do it right now. What is the direction that's being pulled? And we're going to assume 0 is the rightward direction. So if I look at a graph, this is 0. This would be pi over 2. This would be pi. This is 3 pi over 2. So where am I being pulled? And I'm in radians. Where am I being pulled? And I'm going to round to the nearest tenth. So I'm going to have pi my answer, which means I'm actually going to have to multiply by pi. Kind of annoying, but where am I being pulled? Do you remember how to find theta? Theta is equal to, what's the formula? Formula? Something with an arc.
Oh, arctan.
Arctan.
B over A.
B over A. So it's going to be what over what?
It's going to be.
Which one is B? Which one is A?
Oh, it would be -5 over 7.
-5 over 7. Before we even calculate this, what vector or what quadrant should we be in?
2.
We should be in quadrant
No. 4.
4. Yeah, we go 7 to the right, 7 to the right, 5 down, 5 down. We should be right here in quadrant 4. So the answer should be in quadrant 4. I'm going to write quadrant 4. I know I should be there, so if I'm not in quadrant 4, that's a problem. All right, when I do arctan of -5/7, I think I need a calculator for that. calculator. Here we go. I'm going to say 5, make that negative, divide that by 7, and I get that number. Lovely. I love dividing by 7, so it's so random-ish. It does repeat. Okay, and then I take the arctan of that, second tan, and I get negative 35.537, but I'm rounding to the nearest tenth, so negative 35.5. Am I in the right quadrant?
Yes, but it has to be positive.
Yes, it does need to be positive. It didn't really say that. I wonder if that would still be correct.
Because it is correct. It's just the fact that in Khan Academy they would grade us to it.
Yes.
Wait,
So
what?
30.
In Khan Academy it has to be positive.
Why?
I don't know. It was stupid. I got
Yeah.
so mad. I missed it.
I think it was because on those problems you need to be in the correct domain.
Wait.
So I wonder if this would be correct. But let's just go ahead and assume that we want it to be positive, which means we need to do what with this?
You subtract it with 180.
180 is only when you're in the wrong quadrant. Yeah, 360. So we're going to add 360 to our answer, and you get 324.5. So plus 360 to get 324.5. 324.5. The reason we did this, to make positive. Cool beans. That's the first problem in our notes. We're going to do another one just so we get some warm up for our word problems here. So far, so good?
No wonder why I always got the wrong. So bad.
Are we good on the first one? All right. We're on the back side. You already flipped over the paper. I saw you. Oh, Rochelle, you're in this problem.
What?
All right.
Oh.
Who wants to read this one? Daisy, you want to talk about Rochelle?
No, thank you.
Rochelle, you want to talk about Rochelle?
Yeah. In calm waters, you should use this next year, okay? You're gonna use it.
I'll use it next year. Okay.
In the calm waters of an inlet, Rochelle's boat moves with a velocity vector v1 equals 4.5. Once it enters the main river channel, however, Rochelle observes that it is now moving with a velocity vector v2 equals 1.2. What is the speed of the river's current? Round to the nearest tenth.
Yeah, so, and we can visualize what's happening with the problem, right? So we have this B1 vector. We can draw it out here on the side. So we have this B1 vector, which looks like that. Maybe like that. It doesn't really matter. So this is B1. Maybe I can write it. B1. There's our vector. But after it goes into the river channel, it's all the way down here to this vector B2. There must have been some force that caused B1 to move down here to B2. In other words, there must be some vector that did this. What vector is doing that in our problem? What is happening? Why did it go down here to B2? I was going here, but now my boat is going here. What was the change in the word problem? I'm not looking for a number. I'm looking for like a word. What just happened? Yeah, so what's happening?
It changed.
Because what's causing that other vector? What is this yellow vector?
Oh, a hole. Like as if.
So it's just water. Water is pushing against it. So imagine.
Force of water.
So yeah, it's the force of water. So imagine I was just floating along, and then all of a sudden I go off to a new vector. It's because I now have this new water pushing me into this new vector. So that's all that's happening. So this is, I'm going to call this the force of water. Or the force of the river. I guess since I'm talking about a river, I'll do R. This is the river. And I guess you could have just read that right here. It's the river's current is causing that.
What is that?
What is what?
What'd you put on?
R? Trying to say my handwriting needs some work.
I thought there was a square root.
Oh my god. Okay, here, I'll make it nice and pretty, yeah? Okay. And that's the river's current. We can understand this picture? I was here, but I got pushed down here by this R. All right, so I need to find this R. How am I going to do that?
You have to.
And I'm going to give you a hint. It's addition or it's subtraction.
You have to subtract.
Mm-hmm. What am I going to subtract?
Oh, subtract B1 to B2.
So B2 minus B1 or B1 minus B2?
B1 minus 2 minus B1 minus B1 minus B2.
You're correct, yep. Which is graphically the same thing as making B2 go the other direction. B2 goes this direction. Oh, my picture's wrong here. It should have been up like this, but that's okay. It's just a picture to show you how R came about. So I'm essentially making this negative. I'm making this a negative B2, making it go the other direction, and I'm attaching this vector there. Well, that's not quite right either.
That wouldn't be understandable.
See, this is why we don't do word problems.
I mean, I'm bad with them too. I need to work on them more too. All right, so when I subtract them, I'm saying 4, 4, 5, and I'm going to subtract 1, 2. And that will be my missing R. So 4, 5 minus 1, 2, what is that?
Wouldn't it be like 3, 3?
3, 3, there it is. Now let's step back and see if this makes sense. So this vector B2 is 1, 2. This vector B1 is 4, 5. Does it make sense that if I was moving at 4, 5, if I add vector R, I get to 1, 2?
Wait, repeat that?
So let's start with B1. That's 4, 5. I'm going to add a new vector, a new water river vector. If I add vector 3, 3 with vector 4, 5, do I get 1, 2?
Oh no, so it should be negative 3, negative 3.
Yeah, so it should be negative, negative, and here's the reason why it should be negative and negative. These two should have been switched. We should have done our resultant vector minus our starting vector, and I'll just keep that as a star on the side. It's always end minus start. It will always be that way.
Not always.
I guess not always, but for the problem set, it'll be always. So do B2 minus B1 next time. I know I said in the video that you got it correct, but I misled you. Maybe on purpose, maybe on accident, I don't know. So if you just switch those around, you'll get a negative 3, negative 3. That means that these two got switched around as well. It would be 1 minus 4, 2 minus 3. That would give you negative 3, negative 3. All right, we're almost there. We found the vector. I need to find the speed of that vector. What is it really asking for? Speed.
Speed?
What is speed really asking for?
Magnitude.
Magnitude, exactly. It's magnitude and direction over and over again. So I need to find speed, so I'm saying what is the magnitude of R? The magnitude of R, it's nice and curvy, it's not in square root. Magnitude of R is the square root of what and what?
Oh, negative 3 squared plus negative 3 squared.
Exactly. Which is... Good, you're looking at the other side.
Square root of 18.
Square root of 18. We've seen this problem before. Negative 3 and negative 3, right there. Cool, there it is. And we need to round to the nearest tenth, which means I need to do square root of 18, which is 4.2. That's approximately, what's going on here? Approximately 4.2. So far, so good? All right, and now what direction is it flowing? Again, we're doing in radians. I should have said radians here. What direction am I going? So I'm looking for theta, yep. Theta. What is our formula for theta? Arctan, yep, arctan of what over what, Daisy?
B over A.
B over A. In that case, it's going to be what over what?
It's going to be.
Here is our original vector up here.
Oh, so it's going to be
Negative 3 over negative 3, which is just 1. It simplifies 1. So what is the arctan of 1? I can do this in my head because I know what this vector is really doing. It's a nice angle.
Pi over 2.
Close. You're really, really close. Pi over 2 is straight up.
Pi?
And that's straight to the left.
Zero?
It needs to be at this 45-degree
Oh,
angle.
45?
Yeah.
Why 45?
Wait, what?
It's a 45-degree angle because negative 3 looks like this. Shunk.
Oh, so how do you know that?
Negative 3, negative 3. It goes down, left 3, down 3, 45-degree
Oh.
angle.
So
So here's pi. Here's pi over 4.
2 pi over 4.
2 pi over 4 would be right here. 3 pi over 4. 4 pi over 4.
Yeah, I got a clue.
No, you had it. Pi over 4. 2 pi over 4. 3 pi over 4.
Oh,
4 pi over 4.
Is it 5 pi over 4?
It is 5 pi over
Rochelle, he was literally right there.
4.
What did I say?
You were like, I
No.
And 5 pi over 4. You can either do arctan of 1 or 5 pi over 4. Either of those will get you the answer, and I will prove that to you right here. So if I clear everything, if I do the arctan of 1, I get, well, it's not in radians. Let me change this to radians. If I have 1 and I do arctan, I get 0.785. I'm rounding the nearest tenth, so 0.9, or sorry, 0.8. I don't know what I'm talking about, which is approximately 0.8. Wait a sec. 5 pi over 4 is not 0.8.
Ah!
Oh no! That's because this 0.8 is in the wrong quadrant.
Oh, so you have to add 180.
Add 180, but if you're in radians, you add
2
pi. 2 pi would be 360.
Oh, pi over 180. No.
No. Wait.
What do you add?
Just pi.
Oh.
So let me show my work this way. If you just did arctan, you would have gotten 0.8. This is in the wrong quadrant, so I needed to add pi. Add pi because in wrong quadrant. And then you approximately, that was bad, you approximately get this 3.92. 3.92, which is just 3.9. There's your final answer. Let's see if 5 pi over 4 is the same thing. Let's do 5 times pi divided by 4. Hey, look at that. Same answer. Whew. Checked our work. Worked out nice. Okay. Anything else? No, that's it. Any questions? All right, you can write your summary. Your summary is going to have something along the lines of don't forget to be in radians, don't forget to check your quadrant. Those are the main things because you already know everything else. And, oh, when in doubt, draw a picture. This problem I had to solve by drawing a picture. Oh, maybe n minus start. There's a lot of things you could add in your summary. That concludes the notes.